Okay, so let's see. DNA is a chemical found in the nucleus of cells and carries the instructions for the development and functioning of living organisms. In DNA strings, symbols A and T are complements of each other, C and G. Your function receives one side of the DNA and returns the other. So, for example, if we have ATTCG, we get TAACG. So, A returns a T, T returns an A, G returns a C, and C returns a G. Okay, that's easy enough. So let's copy this function. So let's print it here. So we're returning a string, right? So let's do res. I'll just call that as results. We'll make that an empty string. So let's just incrementally work with this. So we'll do a for loop for I in DNA. Let's just print the letter first just to make sure it's working. So we need to call the function DNA strand, and we'll pass through, let's make it simple, and we'll run this code. We got all A's, great. So let's put in a bit more logic. So we'll do an if statement. So let's say if I is equal to the letter or the string A, we will get our variable res and we'll add the letter T to that. So let's see what happens now. So we need to return res, and we'll also now need to print the result of our function, or the return result of our function. So TTT, great. So let's do the next bit. Else if, we can pretty much copy all this. I is equal to T, we'll return the opposite, A. And we might as well do the rest. So let's copy this one. Great. So if I is equal to A, we'll return T. And then we'll do if I is equal to C, we'll return G. And then if I is equal to G, we'll return C. So let's do AT. So now we'll test out our function AT, C and G. It should give us TA, GC. So let's run that. Oh, it didn't print A. So what happened? It gave us T. Oh. So I forgot to do this one. This needs to be T, and now it needs to turn an A. Let's run our code. TACG, great. So this code seems to be working. Let's get all of this minus the print statement, and let's see if we pass. And we did. So let's attempt that. And we passed. Well done.